You know how we're always running out of storage space in the digital world? Our phones, our laptops, even those giant data centers that power the internet, it's like we're constantly hitting a wall. Well, get this. You've been digging into some seriously cutting-edge stuff that could blow that wall wide open. I'm talking about using AI and fractals for a completely new approach to data storage.
It's a fascinating area of research indeed, and you've actually stumbled upon a particularly intriguing GitHub repository, Peter Babulik Synthetic. It caught my eye because it's tackling a fundamental problem. How can we store more data in less space, more efficiently?
Right, because cramming more transistors onto a chip the way we've been doing it seems like it's reaching its limit. But this Peter Babulik synthetic project, with its AI and fractals, is like they're rewriting the rules of the game entirely.
Exactly. And to understand why this is such a big deal, we need to start with the limitations of our current data storage methods. Think about how we currently store data hard drives with spinning disks, flash drives, with memory chips. It's all very linear and physical, limited by the constraints of the materials themselves.
Okay, that makes sense. We're essentially bound by the physical world, even in the digital realm. So, how do fractals break us free from those limitations? I'll be honest, my mental image of fractals is still kind of stuck on that trippy Mandelbrot Zoom video from back in the day.
I understand. Fractals often get relegated to those mesmerizing visuals, but they possess some incredible properties that lend themselves perfectly to data storage. Imagine, if you will, the intricate branching of a tree. Each branch gives rise to countless twigs, and those twigs to even smaller structures. Fractals are similar.
Okay, I think I see where you're going with this. Go on.
Fractals are infinitely complex, yet they exist within a defined space. That's the key. They allow us to pack enormous amounts of information into surprisingly small containers, just like nature does it all the time.
Okay, that's pretty mind-blowing when you think about it.
Yeah.
And the Peter Babulik synthetic repo mentions using various fractal structures, the
Yeah.
Sierpinski triangle, these nested spirals. There's even something called an exponential canopy, which sounds a bit like a sci-fi rainforest.
It does have a certain ring to it, doesn't it? But these names, while intriguing, might sound more complicated than they actually are. Think of the Sierpinski triangle as a pattern of triangles within triangles. Each smaller triangle is a replica of the larger one, and this repetition continues infinitely. It's like a set of Russian nesting dolls, but with shapes instead of dolls. This self-similarity is where the magic happens.
So it's not just about cramming data into these shapes, it's about using the shapes themselves to encode the information in a more efficient way.
Precisely. And that's where the synthetic AI comes into play. Now, I know the term synthetic AI might sound a bit intimidating.
It definitely caught my eye, and not necessarily in a good way. Sounds a little too much like something out of the Terminator, you know?
I assure you, we're not talking about sentient robots here. Think of synthetic in this context as meaning created or composed. This AI isn't replacing traditional storage methods. It's learning how to organize data within these intricate fractal structures. Imagine it's like the AI is composing music, but instead of notes, it's arranging data within the fractal structure.
So it creates this incredibly complex song of data that only it knows how to play back perfectly.
A very apt analogy. And the beauty of it is that this song can be stored much more efficiently than our current methods allow, like squeezing a whole symphony into the space of a single note.
Okay, that's a serious game changer. But how does it actually work? How does the AI even begin to figure out how to store data in these complex fractal shapes? So it's learning, adapting, becoming a master data composer. But I have to ask, how does it actually learn to do this? It seems like it would require a mind-boggling amount of computing power just to get started.
It's a fascinating process that draws inspiration from the way nature itself optimizes. Think about the evolution of a tree's branches.
Okay, going back to nature, I like it.
Over time, the branches grow in a way that maximizes sunlight exposure for the leaves. Similarly, this AI uses a process called evolutionary computing. It starts by generating a bunch of different ways to arrange data within a specific fractal structure. Then it tests those arrangements, seeing which ones are most efficient in terms of storage space and retrieval speed. The best performing arrangements are then bred together, their digital DNA combined to create even better arrangements in subsequent generations.
So it's like survival of the fittest, but for data storage algorithms.
Precisely. And just like in nature, where evolution leads to incredibly efficient and resilient organisms, this process allows the AI to discover storage solutions that are far more efficient than anything humans could have designed on their own.
That's incredible. It's like we're giving the AI the building blocks and a goal, and it's figuring out the architectural blueprints for the most efficient data storage skyscraper imaginable.
I like that analogy. And here's where it gets even more mind-boggling. Remember how we talked about those different fractal structures?
Mhm.
This AI can actually experiment with various types of fractals, finding the optimal one for a particular data set.
So it's not just a one-trick pony with a Sierpinski triangle. It can waltz over to the exponential canopy and start arranging data over there if that works better.
Exactly. It's about finding the fractal structure that best fits the data, like finding the perfect puzzle piece. This adaptability is a game changer because it means this technology could be applied to virtually any type of data imaginable, from text files and images to massive scientific data sets and complex simulations.
Okay, this is blowing my mind a little bit. But there's one thing that always worries me when it comes to data storage. That moment of dread when you realize a file is corrupted or your hard drive crashes. Data loss is not my friend.
It's a universal fear, right? But this is where the elegance of these AI-powered fractal systems really shines. They have redundancy built right in.
Okay, now we're talking. Redundancy is good, especially when it comes to precious data. But how does it work in this context?
Remember how we talked about the Sierpinski triangle being like a set of Russian nesting dolls?
Yeah, with infinite triangles within triangles.
Right. Well, imagine each of those nested triangles also contains a partial copy of the data. It's like having backups within backups within backups. So even if one part of the fractal structure is
You're
damaged,
saying we'd still be able to recover the data from those other copies?
exactly. Think of it like having a puzzle where even if you lose a few pieces, you can still make out the overall picture. This inherent redundancy makes these fractal systems incredibly resilient. They're designed to handle errors gracefully, which is a huge deal, especially as we generate more and more data that needs to be stored reliably.
This inherent redundancy isn't just about peace of mind, though, right? It opens up some exciting possibilities, doesn't it?
You're spot on. The implications of this technology reach far beyond just making our hard drives more efficient. We're talking about the potential to revolutionize entire industries.
Okay, now you've really got my attention. What kind of revolution are we talking about here? So we've got this mind-bending technology that can make data storage more efficient and resilient. But you mentioned revolutionizing entire industries. What kind of impact are we talking about here?
Imagine a world where massive scientific data sets, the kind that take up entire server farms today, could be stored on a device the size of a smartphone. That's the kind of potential we're talking about.
Okay, that's a pretty vivid image. No more giant, power-hungry data centers.
Not necessarily, but we could see a significant reduction in their size and energy consumption. This technology could make data storage so efficient that we could start putting data centers in places we never thought possible. In remote areas, even in developing countries that lack access to traditional infrastructure.
That would be a game changer for scientific research. For one, think of the possibilities for fields like astronomy, genomics, climate modeling. They're all drowning in data right now.
Exactly. And it's not just about scientific advancement. Imagine the implications for healthcare. We could potentially store an individual's entire medical history, genetic information, imaging scans, you name it, in a secure and easily accessible way. This could revolutionize personalized medicine and drug discovery.
It's almost like giving everyone a digital twin that contains all of their biological information, readily available for medical professionals.
A very apt analogy, and it extends beyond healthcare. Think about how this could transform industries like entertainment and media. Imagine streaming 4K movies instantly without buffering because the data can be accessed so quickly and efficiently.
No more buffering. Now you're speaking my language.
Mhm.
But seriously, this all sounds amazing, but what about the real world? Are there any concrete examples of this technology being used today?
We're still in the early stages, but researchers are already experimenting with AI-powered fractal storage for things like compressing medical images and storing genomic data more efficiently. There are even startups exploring its use in blockchain technology and decentralized data storage.
So it's not just a theoretical concept, it's starting to take shape in the real world.
Exactly. And as the AI algorithms continue to evolve and improve, we can expect to see even more innovative applications emerge. It's an exciting time to be following this field, and who knows what breakthroughs await us.
This has been an incredible deep dive. Before we started, AI and fractals felt like these abstract concepts, but now I'm seeing how they could completely reshape our world.
And that's the beauty of knowledge, isn't it? It has a way of connecting the seemingly disparate and revealing possibilities we never even imagined.
Absolutely. So for anyone listening who's feeling as inspired as I am, What's the one thing you'd want them to take away from this deep dive?
I'd say this. Don't underestimate the power of curiosity. You never know where it might lead you. Your exploration of AI and fractal data storage is a perfect example. It's by asking questions and digging deeper that we make new discoveries and push the boundaries of what's possible.
Wise words. So keep those curiosity gears turning, everyone. And who knows, maybe one of you listening will be the one to design the next breakthrough in data storage. Until next time, happy exploring.